previous class, we have learnt about gravitation. Gravitation means the phenomenon of attraction between any two bodies in the universe. If one of the attracting body is Earth, then the gravitation is called gravity. So, we can define the gravity as the phenomenon of attraction between the Earth and any other body. And the gravitational force exerted by the Earth on the body is called the force of gravity. The force of gravity is given by F is equal to G into small m into capital M by R squared. Here, the small m represents the mass of a body. Capital M represents mass of the Earth. R represents distance of the body from the center of the Earth. And F represents force of gravity. As mass of Earth m is large, the force of gravity acting on the bodies is quite large as compared to the gravitational force of attraction between any two bodies of small masses. Next, let us know about free fall. Any object dropped from some height always falls towards the earth. For example, if a leaf and a stone are dropped from the top of a tower, it is observed that the leaf falls onto the ground much later than the stone. Here, the leaf reaches the ground later than the stone, not because of its less mass. Since the leaf has large surface area, it suffers much air resistance than the stone during the fall. Therefore, the leaf takes longer time to reach the ground than the stone. Suppose if there is no air resistance, then both the leaf and the stone will reach the ground simultaneously. Therefore, from this example, we can conclude that the bodies of different masses dropped from the same height hit the ground at the same time if air resistance is neglected. If the air resistance is not taken into account, then the only force acting on the falling body is the force of gravitation of the Earth. This force of gravitation of the Earth is constant and hence it produces a constant acceleration in the falling body. Since the acceleration is produced by the force of gravity, it is known as the acceleration due to gravity. Therefore, we can define the acceleration due to gravity as the acceleration with which a body falls towards the Earth due to Earth's gravitational pull. The acceleration due to gravity is denoted by small letter g. And the falling body on which only the force of gravitation of the Earth acts is known as freely falling body, and such fall of a body is known as free fall. And a freely falling body has acceleration equal to acceleration due to gravity. Next, let us know about expression for the acceleration due to gravity. Consider a body of mass m at a distance r from the center of the Earth. According to Newton's law of gravitation, the force of attraction exerted by the Earth on the body is given by F is equal to G into capital M into small m by R square. Consider this as equation 1. This gravitational force produces an acceleration g in the body of mass m. Therefore, according to Newton's second law of motion, F is equal to mg. Consider this as equation 2. Now, from equation 1 and 2, we get mg is equal to g capital M into small m by r square. Next, we can cancel the small m on both the sides. Then we will get G is equal to capital G into capital M by r squared. Therefore, the acceleration due to gravity is equal to the product of the gravitational constant and the mass of the earth by the square of the distance between the body and the center of the earth. If the body is on or near the surface of the earth, then G is equal to capital G into capital M by capital R square, where R is the radius of the earth. The expression reveals that the acceleration due to gravity does not depend on the mass of the body. Therefore, all the objects, whether it is an hollow or solid, big or small, should fall at the same rate. Next, factors on which the acceleration due to gravity depends. The acceleration due to gravity depends on the two factors. One is the mass of the earth, another one is the distance between the centers of the object and the earth. Here, the acceleration due to gravity is directly proportional to the mass of the earth and inversely proportional to the square of the radius of the earth. Therefore, G is directly proportional to capital M. It means the mass of the earth is more, therefore the acceleration due to gravity on the earth is more. And G is inversely proportional to the square of the radius of the earth. And the value of G does not depend upon mass of the body. Therefore, bodies of different masses are accelerated towards the earth with the same acceleration G. But the gravitation pull of the earth depends upon mass of the body. Therefore, heavier the body, greater is the gravitational pull of the earth, and lighter the body, lesser is the gravitational pull of the earth on the body. Next, let us find the value of acceleration due to gravity. We know acceleration due to gravity G is equal to capital G into capital M by capital R square. Now, we know the value of gravitational constant G is equal to 6.67 into 10 to the power of minus 11 Newton meter square per kg square. And the mass of the earth is 6 into 10 to the power of 24 kg. And the radius of the earth capital R is equal to 6.4 into 10 to the power of 6 meter. Now, by substituting these values in the equation, G is equal to capital G into capital M by R square, then we will get. Now substitute 6.67 into 10 to the power of minus 11 in place of G, and 6 into 10 to the power of 24 in place of M, and 6.4 into 10 to the power of 6 in place of capital R. If we simplify this, we will get 9.8. The unit of acceleration due to gravity is meter per second square. Therefore, G is equal to 9.8 meter per second square. Therefore, the value of G on the surface of the earth is 9.8 meter per second square. Now, let us know the value of G on the surface of the moon. We know G is equal to capital G into capital MM by capital RM square. Now, the mass of the moon MM is 7.4 into 10 to the power of 22 kg, and the radius of the moon RM is 1.75 into 10 to the power of 6 meter. And we know the gravitational constant is equal to 6.67 into 10 to the power of minus 11 Newton meter square per kg square. Now substitute these values in the above equation. Substitute 6.67 into 10 to the power of minus 11 in place of G, and the mass of the moon is 7.4 into 10 to the power of 22, and the radius of the moon is 1.75 into 10 to the power of 6 whole square. If we simplify this, we will get 1.6 meter per second square. So the acceleration due to gravity on the moon is 1.6 meter per second square. Now take the ratio of the acceleration due to gravity on the moon to the acceleration due to gravity on the earth. Therefore, Gm by Ge is equal to, the acceleration due to gravity on the moon is 1.6 and the acceleration due to gravity on the earth is 9.8. So if we simplify this, we will get 1 by 6. So Gm by Ge is equal to 1 by 6, or Gm is equal to the acceleration due to gravity on the moon is equal to 1 by 6 times the acceleration due to gravity on the earth. Therefore, the acceleration due to gravity on the surface of the moon is 1 by 6 times the acceleration due to gravity on the surface of the earth. Next, let us know about variation in the value of G. First one, variation in the value of G with the shape of the earth. We know the acceleration due to gravity on the surface of the earth is given by G is equal to capital G into capital M by capital R square. This expression for G is calculated by considering the earth as a spherical body. But actually the earth is not spherical in shape, but it is in elliptical shape. Therefore, the radius of the earth is not constant throughout. Therefore, the value of G is different at different points on the earth. And the equatorial radius of the earth is longer than the polar radius. Therefore, the value of G at the equator is given by Ge is equal to capital G into capital M by Re square. Now, the value of G at the equator is Ge is equal to capital G into capital M by Re whole square. Consider this as equation 1. And the value of G at the poles is Gp is equal to capital G into capital M by Rp whole square. Consider this as equation 2. Now divide equation 2 by 1. We get Gp by Ge is equal to, Gp is capital G into capital M by Rp square by Ge is Gm by capital Re whole square. So Gm by Rp whole square into Re square by Gm. So we can cancel this Gm. Therefore, Gp by Ge is equal to Re by Rp whole square we can write. Since Re is greater than Rp, then Gp is greater than Ge. It means the value of G is more at the poles than at equator. Next, let us know the variation in the value of G with the altitude above the surface of the earth. We know the acceleration due to gravity on the surface of the earth is given by G is equal to capital G into capital M by R squared. Consider this as equation 1. Now, let a body be at a height h above the surface of the earth. Since the body is at a height h from the surface of the earth, therefore, the distance of the body from the center of the earth is r plus h. Therefore, the acceleration due to gravity at height h is given by gh is equal to capital G into capital M by capital R plus h whole square. gh is equal to G into M by R plus h whole square. Consider this as equation 2. Now divide equation 2 by 1. We get gh by G is equal to gh is gm by R plus h whole square. 1 by G is R square by capital G into capital M. We can cancel this gm. Then gh by G is equal to R square by R plus h whole square. Therefore, gh by G is equal to R square by R plus h whole square. Since R plus h is greater than R, therefore gh by G is less than 1. It means gh is less than G. gh is less than G. This shows that the value of G decreases as we go higher and higher. Therefore, the value of G decreases with the height from the surface of the earth. Next is variation in the value of G with depth. The value of acceleration due to gravity decreases as we go down inside the earth. And at the center of the earth, the acceleration due to gravity is 0. The value of G at a depth d below the surface of the earth is given by GD is equal to G into capital R minus D by R. This shows that the value of G decreases as we go deep into the crust of the earth.